Okay, I think some of you are struggling a little bit with the tutorial questions that you've had to do in the quiz, and having had a closer look at them, they are actually quite tricky. So I'm just going to go through some of the things in the PowerPoint first, and then you can have another go at that. Mrs. Thompson made the questions up and, well, put the questions together, and they're taken from proper exam questions. So some of them are quite hard, but I suspect some of you haven't gone through this properly first. So let's have another look at this, and then you can have a go with it. So I'm not going to go through everything on here, but just a few of the basic things that you need to know. So this bit here, in your circuit, the electrons are flowing in your circuit, and they're carrying a negative charge as they flow around the circuit. They're only going to flow if your circuit is complete. So there's some kind of force pushing those electrons around, and they've got a complete path to go all the way around. The electrons are coming from the negative terminal of the battery, and then they're going round and attracted to the positive terminal. One of the questions in the quiz is related to some of the information on this page. So if something allows electricity to flow, it's a conductor, and if it doesn't, it's an insulator. So conductors then are metals plus carbon, and then insulators are all your non-metals. So this is where some of the math starts to come in. So we've got electric charge. So because it's got a negative charge, we can talk about electric charge. And charge is measured in something called coulombs. Now this is where it gets a wee bit complicated, because everything's got different symbols and different letters. So the symbol for charge is Q, and that would normally be written as a capital Q. And it's measured in coulombs, which is a capital C. Current, so electric current, which is related to charge, is given the symbol I, and it's measured in amps or amperes, which is a capital A. And you've hopefully heard of those before, because we would have done that back in second year when you did electricity. So how are current and charge linked together? So basically, a current of 1 amp means that you've got 1 coulomb of charge going past the point every second. So the charge is how many electrons you've got, and the charge is how fast they're flowing, basically, how many you've got in 1 second. Okay, so if you've got 3 coulombs going past the point every second, that would be 3 amps would be your current. Okay, so the current, so 1 ampere or 1 amp is 1 coulomb of charge every second. So the current is the rate at which they're flowing. So here's how it links together in a formula. So charge equals current times time, which is then written as Q equals IT, which you can see has gone a bit, that should be in a box, it's gone a bit wonky on the PowerPoint. If you put that into a triangle to try to work out some of the other things, so if you're working out charge, you do current times time. If you're working out current, you'd be doing charge divided by time, and if you're working out time, you'd be doing charge divided by current. So same as all the other equations that we've used, okay? So there's one example given, and then there's some more for you to do. So if you've got 348 coulombs passing the point every 2 minutes, it's asking what the current is. So if we go back up to here, so current is going to be charge divided by time, okay? So there it is there, current divided by time, 348 divided by 120 gives you 2.9 amps. So the A's jumped a wee bit, it's not lined up properly on this one. What you've just got to watch is that the time needs to be put into seconds. So it said every 2 minutes, so you need to make it 120 seconds, okay? Right, so then there's a load of questions for you to do. I'm not going to go through those now, but if you want, I can do a separate video or a Teams call or something going through these questions. Mrs. Thompson is going to upload the answers, but I can go through those if you want. So you're just using that formula, that triangle that you've just used, to work them all out. So you need to look each time whether you're working out current, whether you're working out time, or whether you're working out charge, and then just rearrange the equation. Make sure you do these before you move on, okay? So stop there, stop the video now and do these 5 questions, and then carry on later on. So the next bit then is looking at this thing called voltage. So voltage is basically to do with how much energy those electrons have got as they're going through, okay? So for example, a 6 volt battery would give the charges twice as much energy as a 3 volt battery. Now another word for voltage is potential difference, because it's about the potential to do something. How much potential have they got to basically pass on the energy? And then difference is because you're looking at how much energy they have before they do something and then how much energy they have at the end after they've done it. So voltage, measured in volts. You've then got some circuit symbols. Make sure you've written these down, and these are the basic ones that you do need to know. There's a whole load of other ones that you'll come to recognise as you see them, but these ones you do need to know. Okay, so you just need to learn them. Just write them out and learn them. And one of them is asked about in the quiz, so make sure you use this to help you. The quiz isn't supposed to be a test. You're allowed to use your notes to help you do it. So there's a resistor. Oh, sorry, I'll just go back up here a second. So an ammeter is the meter that you use to measure current, and a voltmeter is what's measuring voltage. A cell and a battery are similar. So a cell is a single cell, and a battery is actually lots of cells joined together. So that's just two different ways of doing a power supply, basically. Or a power source, not power supply. You've then got resistor. So a fixed resistor and a variable resistor. We'll come on to what they are later on in the topic. A fuse, that's a safety device that's put into something to stop, which then basically breaks if the current gets too high. Switch and lamp, fairly obvious. There's two different types of circuit. So series circuits and parallel circuits. So if you've only got one option about where the current can flow, so everything's just on one loop, then you would talk about them being in series. So those 3 lamps are in series, but obviously they'd have to be connected up to a power supply. If you've got more than one choice about where to go, so if you look at the arrows on that, you'll see that coming from the left, the current would be flowing in through that wire. When it gets to that junction, it's got a choice. It can go through the top lamp, the middle lamp, or the bottom lamp. And it'll go through there, and then they'll join back up again. So that would be a parallel circuit. Oh, now this hasn't got loaded quite properly. I think it's just because I'm on the iPad. So what's that saying is that current is measured with an ammeter, and an ammeter would be connected in series, so it's connected right into the circuit. So that little circuit there, you've got a battery, then you've got a resistor and an ammeter, and they're connected in series, and the ammeter would be measuring the current. Voltage is measured slightly differently. It's measured with the voltmeter, but the voltmeter is connected in parallel or across what it is that you're looking at, and that's because it's looking at how much energy those electrons have got when they go into that resistor and how much energy they've got when they come out, and working out the difference between the two, and that's the voltage. Okay, now this bit you'll need more work on, but it comes up briefly in those questions from Mrs. Thompson. And no, we're going through everything really, really quickly. We're going to basically just give you lots of theory stuff and as many questions as we can, and then we'll actually get the circuit stuff out when we get back into school and have a look at it. So in a series circuit, the current is the same everywhere. So that where it says IA, IB, that basically just means the current at A and the current at B and the current at C, and so on and so on. So because the electrons have no choice about where to go, the current is just the same anywhere in that circuit. So it doesn't matter where you put the ammeter, it would always record the same number because it's looking at the numbers of electrons that are flowing around that circuit. Whereas voltage is shared between them. So the voltage, remember, is connected to how much energy those electrons have got. So the electrons are given their energy from the battery, they go around the circuit, they've then got to share that between the lamp and the resistor. So it's going to be shared between the two. So the voltage at A and B are going to add up to be the same as the voltage across the battery. So say the battery was 6 volts, they could get 3 volts each, or it might be the lamp gets 2 and the resistor gets 4. If you knew one of them, you'd be able to work out the others. Well, if you knew 2 of them, you'd be able to work out the third one. Current and voltage in series and, in parallel circuits is a little bit different, and I'm actually not going to go through that just now, so don't worry about that one at the moment, okay, because that's a bit more complicated and needs a bit more time spent on it. Right, some more tutorial questions. So again, I can do a separate video actually going through these, if that helps. But if you use the notes and then the extra little bits of information that I've just told you, and this helpful hint here at the top, you should hopefully be able to complete these questions. Okay, so current is the same everywhere in a series circuit, and the voltage is shared amongst the components. So that should help with that first one. And the second one. So this one, the 36W, that's to do with the power, but ignore that, you don't need to worry about that. Okay, so you don't need to know that to be able to answer the, it's not relevant to the question, it's just there, it's there as an extra number, okay, but you don't need to know it. And then we've got another one, two more resistors connected in series. So again, with this one, we've got units there that we've not seen yet. That funny little symbol after the 200 and the 100 is called ohms, so it's 200 ohms, and that's just the unit of resistance. But again, you don't actually need to know that. It's not, you don't need to know anything to do with that to be able to answer the question. You're still just looking at what's the current everywhere in the circuit and how is the voltage shared everywhere around the circuit. These ones, have a go at them, but don't worry about them if you can't do them, because like I said, I think these need a bit more time spent on them to go through them properly, so we'll do that another day. Okay, that's definitely a difficult one. Okay, hopefully that helps a bit with the questions that you need to do in the other activity in the quiz. Something just to watch for in the quiz is the units. So there's one question that's in milliamps. So I think it's 4 milliamps. 4 milliamps is 0.004 amps. And there's one that's microamps, which is times 10 to the minus 6. So you need to watch that. And then also the way that one of the questions is laid out is a little bit tricky to see, but it should be, it's sort of times 10 to the 2 or times 10 to the 3, where the numbers should be up at the top, but they're not. It's not shown properly. But hopefully that'll make more sense when you actually look at it. Give me a shout if you need any help with anything.